the process of what we're going to go through here, you guys are going to fly right through this. All right? The word problems when we start talking exponential growth, exponential decay, are extraordinarily easy to work with. Okay? You've probably worked with some exponential growth and decay modeling already. If you guys have done anything in chem, you'll do radioactive decay.
Not yet.
Not yet. Eventually, you will see something like that, where certain isotopes decay at certain rates. Carbon dating, you ever heard of that?
No.
That's
how you see how old it is
by the carbon, because you know what the half-life of carbon is. It's things like that. That's all exponential. Okay. When you're working with what is it called? Checking accounts or savings accounts, if you're earning interest, stuff like that, those are exponential growth stuff. A little actuarial stuff, there's things like that. These are real world application style problems that are very, very easy to work with. Yes, ma'am? All right. So what I want to do here is kind of show you guys the growth models first, and then we'll go into the decay models, do a couple examples, and call it a day. All right? So I also want to talk a little bit about curriculum junk. We'll do that at the end. I need a whole lot, 3 minutes maybe. So here we go. We've got this exponential growth modeling. Exponential growth modeling is extremely simple to work with. You have this generic function, y equals a times the quantity 1 plus r to the t, where a is your initial amount, r is your rate. It's in a decimal form. They usually say it's like 4% or 16% or something like that. So you just have to, I know, you have to convert a percent to a decimal. I know it's a tough thing to ask you to do. I know. And T stands for time. It's usually in years. Oh, thanks, sir. You did that last time, too. You just don't like the paragraph.
It's a habit of just going in there.
I know. I know. You just have to trust me that there's methods to my madness. Okay. This stuff that we see here, we label things out. We have this 1 plus the r is what we call the growth factor. Yes, sir.
So for the time, will be different symbols for each?
What do you mean?
Is there going to be like a rate of time?
Oh, no. It'll be like 6 years, 2 years, things like that. It's usually time in years. You'll see it as we go into it. It's very, very easy to work with. Okay, it's very easy to work with. You got the initial amount. R is your rate as a percentage, and that 1 plus r that jumped in the parentheses is called your growth factor. Okay. So let's see. We have y equals a 1 plus r to the t. And this is what it would look like. You got a population model. This place in Nevada has a population.
What is the name of the plants?
Winnemucca, I think.
Yeah. I think it's
Or Winnemucca.
Why don't you use Google Translate? You just type it in.
I'm busy. Your population, 6191 times quantity 1.04 to the t. And that's the thing, a lot of times they give you the model right up front. They're not asking you to create the model. We'll do that later, given specific data sets. And then they say T is the number of years since 1990. So 1990 is year 0. That make sense? That's
Yes. Sarah.
So when you start, you have anything raised to the 0 power. What is anything raised to the 0 power?
1.
It's 1. Therefore, that means your initial is 6191. Does that make sense?
Yes.
Because if your T is 0, that's where you're starting at. Your initial amount, your A value here, is 6191. In 1990, there were 6,191 people living there.
It's like small city.
Right?
Is it true there's like 4,000 people in the count?
With the
Counting with
students.
you?
I don't think that's.
It's 37,000. My dad does the census.
I thought that they couldn't count the university. Yeah, they don't
Well,
count.
it's when they count the universities.
I don't know.
I don't think it,
I don't think they count it.
so it's like 12.
Does anybody else know?
No, because there's
There's
like,
like 25,000. Okay, sorry.
there's like 20,000
All right.
at the university.
So, in this case here, what is your rate? What's your rate?
1.0.
Wait,
100 is
no, it's, no, it's 0.04. 0.04.
Guys, when I'm asking about the rate here, I'm asking what is the rate? The rate would be is 0.04, so it's 4%. Okay. That 1.04 is the growth factor. Okay, that's how fast it's growing.
Oh, I forgot.
Okay. So you're looking at the growth. You're looking at this part for the rate. The decimal part is the rate. And we just usually say it in terms of percentages.
Wait, so if it has, say it went by every 2 years, would it be 2 plus that? Just say it was like that.
No, you're thinking of a different style. It's these growth ones are bless you. What you can do is
Yeah.
it can be compounded differently. That's what we're talking about, interests, and you'll see that in a second.
Yeah.
Yes, sir.
What was 2.04?
If it was 2.04, it would be 240%.
Wait,
Your rate would be that much.
no, it would be 100. 2.04.
Oh, yes, I'm sorry. Yes, 140%. Excuse me, sorry. Math is hard. I get it. Adding is really difficult. I know. I know.
Guess on it.
Why
So-
make us do it?
Let's say you want to figure out how many people were there in, what year would be, let's say 2007.
And I got it wrong.
So what is your value of t then in 2007? Bless you. It would be how much? 17. So you can put this literally into your calculator, the way it sits.
So we will get calculators for this one?
You have to. I can't make you do this by hand.
Good guy, Mr.
So you'd have 12,059 people. You usually, when you're dealing with population, you're rounding to the nearest whole person.
So do you round down or round up?
It depends on how you're rounding. If it was 0.5 or above, you'd round up.
More than, or less than,
So
more than 4.
Hannah, what are you saying?
There's about 12,000 people there.
There's a half a person.
More
Who's
than
gonna have
less than
to-
4 than a tragic car accident.
What's that?
It's not good time.
I didn't. That's a different problem. You can put those in. This is a good. I have it up here. You could put these in your y equals and look at your table and watch them all go through throughout the years. You can do that as well. That does work. We do look at that sometimes when you're trying to answer some questions. It does come up. All right. Like I said, guys, like I said, these are very straightforward style problems. The biggest concern that most people will screw up, if they ask you what the rate is, what's the percent of increase, you're going to do this wrong. You'll say it's 0.04% instead of saying 4%. Compounding interest. This is the money stuff. This is the when you're going to your bank accounts.
Hannah really wants to be an accountant.
So
Wait, are you serious?
when we're looking at these, it changes the values just a little bit. Just the what do you call them? Variables. Your overall amount, your total amount, is equal to some principal. P stands for principal. Principal is your initial amount. How much money did you put into the bank to start with? 20 bucks, okay? R, again, is your rate as a decimal. This value of n is the number of times it compounds. What that's supposed to mean is if you have something that's compounding monthly, that means your interest is calculated 12 times a year. If it's compounded semi-annually, it means it's compounded. It's twice. If it's compounded quarterly, it would be 4 times. If it was compounded daily, it would be 365.
So instead of finding the rate per year, we're finding however often you check it, right?
Yeah, it depends on in each account. There's certain banks will do certain things. Yes, ma'am.
So is it better to have it like semi-annually or every day?
Well, you'll look at the numbers. If it was every day, it's going to grow quicker.
Okay.
All right. And it just depends on your values. T is still the number of years.
Is it always used?
Yeah, when you're talking about compounding interest style problems, you're looking at T value will be in years. Okay. You're going to have X amount of dollars in a bank account compounding quarterly for 20 years. That kind of thing. So when you walk through this style, again, it's very, very easy to work with. Your overall amount is your principal, 1 plus your rate divided by n, and the n times t. Now, if I want to look at an example, you're depositing $1,000 into an account that has 8% annual interest. Figure out the balance after 1 year if it's compounding annually, quarterly, or daily. And you can see how the interest is changing, how that changes. That's all you're doing.
So the rate is.
Yes.
Okay.
So when we look at this, if it's annual, what's your end value? 1. Quarterly, what's your end value?
366.
Yeah.
366.
Yeah, well, I
5.25.
think they use this. So your principal, your rates, those don't change. Your principal, your original amount was still $1,000. Your rate is still at 8%, so it's 0.08. And your T, 1 year. Okay. So after 1 year, you can easily substitute these in to see how much you're going to have. Little trick to show you here in the calculator. If you type it in exactly the way you would write it out, we'll put this over here so I can have it up. It's 1,000 parentheses 1 plus 0.08 over 1 times 1 times 1. I'm doing the first one for annual. You type it in exactly like that. And I know this is kind of redundant by putting all these extra values in here.
Just a few ones.
Oh, boy.
In a year, you made $80 in interest. Well, what's 8% of 1,000? 80. So you made $80 in interest on that 1 year. Now, as you go through, the next one was quarterly, I believe. What's the only thing that's got to change? That changed. It's going to be 0.08 over 4 and a 4 in the exponent. So do you guys know how to overwrite an equation?
Yeah.
It's second entry, and it comes back up. Back over the values and just overwrite it with the 4s. You look like you're just totally astonished right now.
Sorry, I'm trying to copy down notes from there and listen to what you're saying.
Oh, okay.
Here. So it's like,
A lot.
yeah.
So if I go back over these,
Why do you change the exponent to 4?
because your new end value is 4, is the second problem.
So why did you give you 1,000?
What's that? This is what you're starting with.
Oh, okay.
And if it was compounding quarterly, you basically make $2 more than you would if it was compounding annually.
So that's how many times?
Correct. Because if you think about it, if you're compounding it quarterly, that means after the first 3 months, they're going to give you all this interest. So now your new amount has changed to more money, which means you're going to make more interest, which means you're going to make more interest the next time. So it's just compounding itself up a little bit more each day.
So
Okay.
daily must be like crazy.
Daily is just off the chain, as the kids say.
Nobody says that.
I have
Not
no.
kids anymore.
As the peeps.
Oh, so you would make
It's even worse.
You could, no.
The gangsters.
So I'm going to change this to what, 365? It's a whole extra $1 more. Because remember, your growth factor isn't that big because you're dividing it up by 365, so it's going to be a smaller amount raised to a higher exponent. So It just works out to be that way. So you wind up these different, you work out these different values. So as you start to, actually go to banks and you want to figure out different savings accounts, or, I would say just get a job there, but if you're looking at where to put your money into what type of account, you can use these very basic formulas to give you a rough idea of what's going to be the best bang for your buck. You know what I mean?
Interest is definitely not 8% because
What's that?
you get like 3 pennies.
Yeah, interest is not 8%. It's like 3 or 2%.
Oh man, I
It's
was
awful.
really
I seriously
excited.
get like 3 pennies.
Yeah, and then you spend like $20, like,
I spend all my money in my account.
Yeah, I think every year I got
It's a really good
save.
All right. Like I said, you guys can see that these types of problems are very, very easy to work with. Do you agree, I hope?
No,
Right, yeah.
Smiley face was
I'm not agreeing.
All right. Try this one. Do quarterly on this one for me, please.
Just quarterly?
Yeah.
It would be in there.
I'm sorry, what's that?
Do you get 909 like total or 909 on top of the 500?
Total, because what you're finding here is your overall amount is the initial amount, 1 plus your rate over the end. So you're starting out with, the 500.
500.
Alright, sounds Gucci to me.
You got what, 900 and some change? Does that make sense? So yeah, even though it sounds like not a lot, and banking can be kind of boring, because it takes a long time for things to work.
Especially when you're writing in line.
Now the other one you deal with a lot, the other one we deal with quite often, which is another thing that's very, very common to work with, is something called depreciation.
Oh, that's something.
I've heard of that. Well, I mean, it says depreciation. It sounds like the opposite of appreciation.
Exactly bad.
It sounds like depression.
It's depreciation.
Depreciation is exponential decay.
Oh. Wait, so what's the other thing?
Exponential growth.
No, I mean like appreciation, because there's another name for decay. Is there another name for growth?
Not that I know of.
Can we just call it appreciation?
Whatever. So, like I said, exponential decay is kind of like we talked, like radioactive decay, when you do carbon dating. Depreciation is when you're looking at like a value of a car isn't worth as much after you drive it off the lot, things like that.
It drops like $10.
Yeah, and some cars will depreciate faster than others, depending upon the style and brand. What's that? Yeah. Yeah. Brand new cars depreciate faster than a used car. So if you have a brand new car that's $40,000, the day you drive it off the lot, it might be worth $30,000. That's how fast they depreciate. But if you have like a used car,
It's already
someone's already taken that depreciation hit on that and gone from there. Oh, that was Lee. I was gonna tell him something.
Yeah, wait, can you have him come in?
Hey, Lee. Lee.
Yeah, he was just speaking out like a Christian. I thought he was talking to me.
Lee brought this stuff up last year when we were talking when we did this stuff in lab, where we did depreciation and growth and all that. You would figure out not only the year things were worth something, you would also do it in June.
Yeah.
Oh, fun.
It's good conversation.
Sounds
It was
good.
good fun.
Have fun with that.
Thanks. What's we figured video games are depreciate about as much as cars do the other day.
Oh, you did?
Yeah.
Nice. I didn't know that. The rate's about the same?
You buy a $60 video game and it depreciates down to about $10-15.
That does that pretty quickly though, doesn't it? After
Yeah.
that, depending upon how fast it's being renewed into a new version.
But you open it up and it goes down like 60-some%.
Huh. I didn't realize it was that much.
Very good.
See? Real world applications. Ladies and gentlemen, Lee Williams. Now, it was like, when you was talking about the whole time in June, there was, you'll see, there's going to be a homework problem that it's going to ask you approximately what year or when did something equal some value. I'm not lying, he showed me how he figured it out. He was able to figure out what month it probably occurred in. He's a little out there sometimes when it comes to this math stuff. He's very good when it comes to numbers, let's just say. So depreciation. Like we were saying, cars depreciate real fast. Basically, just about anything can depreciate that you buy brand new. Do you guys know by chance what brand of car depreciates usually faster than others?
Lamborghini, whatever one.
Ford.
Toyota.
It's really expensive ones do tend to depreciate a little bit quicker than others.
Nissan.
It depends.
Audi.
I mean, not usually that. Some of the car stuff that depreciates usually the fastest are ones that aren't highly rated. You guys know of a thing called Consumer Reports?
Yeah.
I don't know if that one, but I know.
I hate the way that car looks.
Exactly.
It is pretty ugly.
So
It's a
ugly.
box.
One of the things that tend to depreciate really, really fast are like Chryslers and Dodge.
Smart cars.
Why? Because they're not rated very highly.
Really?
Yeah, they're not rated very highly. They're people don't buy them as often. I mean, the cars that don't. What's that? Well, it's not. I mean, it's not Ford or whoever. It's just that a lot of the cars that usually are the cars that more people rely upon, the cars that more people buy. Like Hondas,
Like a Camry.
Camrys, and stuff like that. Those things don't depreciate as rapidly. Fords, trucks don't. Trucks and SUVs used to depreciate big time when gas was $4 a gallon. And then that's why you wouldn't buy a new one, because if you did buy that Cadillac Escalade at $80,000 off the lot, the minute you drove it off the lot, it was worth $40. That's how fast they were taking those depreciation hits. Because people weren't buying as many of them because of the gases and stuff, the gas prices and all, and they weren't very efficient. So they just would take this giant hit on there. Right. You gotta throw your 24s on it. But it's just one of those things that as you guys start to, I know I'm hating, as you guys start to buy stuff and you look into where your money's gonna go, you'll look at these little things about what cars would have better resale value after 4 or 5 years, even something you're not gonna keep. They're all over Europe. What's crazy about the smart car, a lot of those in Europe are diesels. And they get good mileage. The smart cars in America, I mean, you could buy a Honda Civic from 97, 98, like right around 2000 Honda Civic or so. It's going to get better gas mileage than a smart car does now.
Don't get smart cars.
It doesn't. The regulations are what happened. Regulations and safety. Cars nowadays are so unbelievably safe. They really are. You go back to when I was in high school. If you weren't driving, my buddy had a '79 Mercury Cougar. If you don't know what that looks like, the car was probably about where I'm standing to that wall. That's how big that car. And they only had 2 doors. You don't. It just kind of you anchor it really because it's a landing. But they had so much steel and stuff all around it. But then cars got cheaper, a lot cheaperly made, and they didn't last very long. But now cars nowadays are nicer. They're safer. The plastics, everything in there are thicker, heavier, bigger. I mean, just like, for example, like a Honda Civic. That's a real basic starter car, if you think of it that way. They're not terribly expensive. They're extremely reliable. They get good. They're still expensive. I mean, don't get me wrong, but for like a basic little car like that, a Civic that you buy now, what are they, 22, 23 grand, something like that maybe? I don't know. We'll say they're 24 grand, okay? That same Civic, when I was in high school, was probably 12. Because there was less safety features in it. We didn't have airbags when I was in high school. Nowadays you've got like 15 airbags in your car. It's a giant marshmallow. You actually have a shoulder belt. Yeah, you had shoulder belts. I mean, when we had those, I mean, it's a lot of stuff. So cars, and people were dead. Population control. But now it's like you have all these other little things. But yeah, depreciation, the only difference between depreciation and growth is that your growth rate is now a subtraction symbol. Minus the rate. That's the only difference between depreciation or decay versus growth. Sir?
When you say like, it depreciates from when you buy it to when you drive it off the lot,
Yeah.
you're saying like just in a matter of few hours or days, it can depreciate that much?
Yes. Yep.
So like if, say, you bought it for 30,000, and then by the time you drive it off the lot, it's 20,000, the guy driving onto the lot will buy it for 20,000, is it legal?
They would, but then you took a $10,000 hit.
Yeah, oh, yeah, I know, I'm saying, why would the guy that, and then
Yes.
the guy that drives on and gets it for 20,000, but then he loses 10,000.
It's not so much that, and it's a good way to think of it this way. Let me finish this real quick. I promise I'll answer your question. I do, I promise. What happens a lot of times with cars and how things are sold through, when you buy something, use your example, it was $30,000. And the minute you drive it off the lot, it's no longer brand new.
Yeah.
You drove it, okay?
Oh, okay, yeah.
So now the resale value of that,
Oh, resale.
and that's what I'm talking about. What is it
I thought
worth?
you were just saying like they're going to be selling their new Civics.
No, okay, all right, you
that'd be so
might have
cool.
misunderstood me
Like
then.
$1.
So what happens is, when you,
Yeah, all right, I
when
get
you,
it now, that makes sense, that makes more sense.
all right, because then, that's why a lot of times people buy used cars, because that initial depreciation hit has been taken by somebody else.
It's used, even though it might only be used for such a long.
Correct.
Yeah, okay, yeah.
And that was one of the things that we
That
did.
makes more sense.
And it's a good thing to look at, because you can get more car for your money
Yeah.
by somebody else taking that hit. And I did that when we bought a Suburban like 5 years ago. You know, when we got that, it was because somebody else took the depreciation hit and gas was $4.50 and nobody wanted to buy a Suburban.
Yeah.
So I got a heck of a deal on it.
Looks like when you return
Yeah,
your
it's
car to the even though.
Ma'am.
You kind of answered what that
Oh, okay, good job.
Yeah, no.
All right, so the only difference between growth and decay, your A value is still your original amount, your R is your rate in a decimal, come on guys, and T is time. It's 1 minus the rate now, and that's how you're able to tell whether or not it's growth or decay.
So there's no T times that?
No, this one is the, yeah, the one with the N, that is just for compounding interest and working with money. This is just your straight depreciation. So here's your example of the car.
Depreciation won't have. Wait.
Ah,
No, what if they calculate their depreciation quarterly?
Stop talking to me.
Come on.
Now, this one here, yes ma'am.
Go back, slide.
And I'll use the example of the car.
I got to look at you, but
Watch the video later.
Yeah.
And don't get me wrong, there are cars and stuff that hold their value better than others. There always will be. I mean, nowadays, trucks are holding their value tremendously. And one of the reasons why trucks are holding their value is because gas is cheap. So you don't see as much of a hit on that. So as we get into like an example, here's the example where you're buying a car for 24 grand. The value of the car is decreasing by 16% a year. How much is the car worth after 2 years? So when you write this out, you're going to see a lot of this same wording when we get to the homework problems where it's going to ask you to graph the model. I'm not going to ask you to graph models, okay? Because you're going to use your calculator for a lot of this. There's no reason for us to be able to do that by hand. Unless you really want to. A lot of these things you're going to be able to model and look at your table stuff. Yes, ma'am.
Because I wonder if there's campus like 24,000 times the 16%, and they just like take that and subtract from the.
Well, what's happening here is that you're finding, by doing that, you're finding 16% of the 24,000, but you don't know how much you're taking off, and you have to continually do that. Okay? That's what this thing allows you to do. So here you've got your model then, your initial amount, 1 minus your rate to the time. So it's your 24,000. 1 minus the 0.16, and in this case, they're asking for it for 2 years. Now, I'm going to do something a little bit different with this problem. Instead of just putting it directly into my calculator to get the answer, I know that I have to figure out, it says use the graph to estimate when it's worth about 12 grand. I'm going to put this into my y equals function. So put this in your y equals function like this, but instead of putting a 2 there, what am I going to put? X. Yeah, it'll be after 8-3. My guess is we're going to do 8-3 stuff tomorrow and Wednesday. I'm trying to do, maybe we'll just try to do it for Friday, because logs, I don't want to split logs up over a weekend, so we might just stretch this for a couple of days. It's no big deal. So if I put this into my y equals table, and I look at it, notice again, at 0, it's 24,000 because that's the original amount. After 2 years, it was worth 16.9. No, it was, I'm sorry.
Because after each year goes down, sure.
But remember, it's going down 16%, then it's new value, then a new value, so it's coming off of that. That's why it's not, if you did it that way, it would be going linearly, a linear decrease. This one, it's taking it off each chunk. Exactly. That's why it's dying. Yes, sir?
Okay, so is there like a rate for like each time you like wreck the car, like we have it fixed?
Yeah, absolutely. And there's things, it's not like a standardized method for each car, for each thing. Each car in and of itself is a different model. It really is. You know, you're going to have different factors weighing in where you live versus where the car is driven, how many miles you drive, things like that. Living in the northern, where the salt is, the salt eats up your car. Whereas if you're in Florida or California, those cars don't have any rust on them. So you get a lot. Get out of my room.
Guess what? It only takes 84 years before you get this car for a penny.
But will it ever be worth a penny?
No.
No. And that's kind of the idea here. Claire just brought up a good idea. Claire just said that after 84 years, the car is going to be worth a penny. Will that car ever really just be a penny? It's not going to bottom out. It's going to approach to a value. It's going to wind up leveling itself out. I wouldn't say even an aspect, but you're right. It has that decay factor to it, but it's not going to it's not just going to stop.
Just wanted free car.
This is good. I mean, this is someone could be like, hey, this is a gift for this 80-year-old car. And we're like,
Okay, so buy a car now, and when you're 80, give it to somebody.
No, but it'll like opposite, because you know it'll go down for a certain period of time, and then it'll become like vintage.
Right.
So it'll start going back up.
Mhm.
You gotta feel like,
Bam!
you need some parabola. You get really good.
What was your question earlier? You had your arm out too.
Oh, no, I know. Good job. Then it gets vintage. That car.
That's boring. Then you get some homework problems.
I don't want to.
Yeah, there's not a lot of crazy stuff yet. Yeah. Oh, let me just open it out of here. Yeah, I'm just getting the problems, so I forgot to write them down.
Hey, they have 2 cars and they only drive one of them. My grandpa can't even drive anymore, so it just sits in their garage.
So you're thinking someday you might get a car from Grandma and Grandpa?
I'm not gonna, because it's a nice car. So it would go to my parents, but I want like my mom's car. If they get that car, that was originally a plan, but then they're like, nah. They drive me.
Do these, please. Okay. Now, on these problems here, you'll notice that I wrote for some of them, it says no graphs. Just like the example we just did a second ago with the car depreciation, it said part B to graph it. You don't need to worry about graphing them. I want you guys to be able to use your y equals function. Go to the table and look for values. Okay?
So what you did was you did the beginning of sec A1 and A2, and then you went back and did all this.
Yeah.
I was gonna say, didn't we just do full sentence?
We did, yeah, and I do this a lot with some of these types of things because I think that it tends to be a little bit too much to do all the graphing, the shifting, and all that, and then throw in the modeling with it at the same time. Why not do all of it together and then dump it out? It does seem like it's a lot, but I'm not lying to you. This should not take more than 20 minutes. Really, it's a very, very easy set of problems. Okay?
Last night's homework, that's not everything.
Oh yeah, there is pre-calc and pre-calc honors.
Thanks.
Welcome.
Honors pre-calc? Guess what I'm not taking?
I don't want to.
I'm not taking honors.
Wait, we've never, is there honors pre-calc?
You guys do it?